Here we are in Cass, West Virginia, and this is Cass Scenics number 11 Shea engine. These locomotives are geared drive. Everything drives, even the tender trucks. The drive shaft that runs the whole length of it. Cylinders are on the side.
Hi, and welcome to another old steam powered machine shop. That clip you just saw was from the Cass Scenic Railroad in Cass, West Virginia, and it's another item crossed off my cousin Rusty's and I's bucket list. And we had a great time out there. It's a railroad that was constructed about 1900 to service a huge logging operation out there. And some very forward-thinking individuals managed to preserve it and save it. It's in the hands of the West Virginia Parks Department now, and they run trains every day during their season. They have their own shop, and they're overhauling their own locomotives there. They have a total of 6 Sheas. The one in the video at the beginning of the video is the largest Shea engine in existence today, and they're gear drive locomotives. They're sort of like the four-wheel drive Jeep of locomotives, because there's some very steep inclines, and it's a long pull up through there, and they haul it all the way to the top, to the summit. I want to thank Mark Farnsworth and John Gilmore, who gave us a great tour of the shops. Mark is actually the resident railroad carpenter in charge of all things wood, including making all the fixturing and the cab woodwork and everything on the Heisler engine that they're rebuilding in the shop. John is a hustler, And he comes on at 7 o'clock at night and stays with the locomotives all night and keeps them hot, fired up, water in the boiler, ready to go in the morning for the first run. We also got a tour after dark, so we were running out of daylight, of an old burned out, abandoned lumber operation that had a huge coreless engine on the second floor of a brick building that was pretty dilapidated, and it was quite a trip through the boonies to see that. And I really enjoyed it. Thanks a lot for the tour, guys. The machining segment of this video, which is number 50, it's a big 50. Man, I never would have believed we'd have got 50 videos, but it's not like being 50. It's 50 videos, but being 50, that seems like a long time ago for me. As long as you guys are interested in what I'm putting up, I'll put it up. But you gotta let me know. You gotta give me a like or a subscription if it's something you think you'd like to see on a regular basis. And I'll try to keep putting up videos during the winter time. And this video that's coming up now is a job that I did this fall, and it's another sleeve job on a hit and miss engine. I've done, I think there's two other videos, and it's kind of a common thing, but I thought you'd be interested in seeing it, even though it's not, the boring mill is not powered by my steam powered line shaft. So we'll get right to boring and sleeving the cylinder. Thanks a lot, I appreciate it. Talk to you later. I get some questions about licensing boilers. This particular boiler I had no paperwork on, and the stampings on it were barely legible, and I figured in New York State it would be just about impossible to get it licensed. But in the last couple of years, they have made some changes in the way they do business. Every state is different. Some states have no inspection at all. New York has always been kind of tough. But they required a ultrasonic thickness test, which is not a bad idea anyway. So after going through a big deal with finding a legitimate testing service, I had this thickness tested, and their resident engineer ran all the calculations just as if it was being designed as a new boiler by National Board Code, which New York State doesn't necessarily go by. They go by a lot of their own stuff. Some states go strictly by the National Board Code, which has been around since 1890, and they've kept up with it with the new technology and everything, and it's basically used in all pressure vessels these days. So anyway, with the ultrasonic test, they do once a year what's called an internal inspection, where all these handholds are taken out, and you look in there with a flashlight, look around, look for corrosion, look for, I don't know, whatever they think they're seeing. And then a second inspection at a different time. They'll come back when the boiler's under steam and check it, and you run the pressure up till the relief valve blows off and make sure that the gauge reads what the relief valve is set for, and that's a separate inspection. And then every 4 years you have to do what's called a hydrostatic test, where you fill the boiler full of water and then very carefully pump more water into it, which very rapidly brings the pressure up because water won't compress. And you run the pressure up to like 25% over your maximum pressure or whatever they want you to do, and you check for leaks or anything going on there. And if it passes that, then you're good for another 4 years on that test. But it still has to be internally and externally tested once a year. And I'll show you.
certificate right there.
I want to show you how this sleeve job is going along before I get too far into it. This is a 5.5 inch bore international hit and miss engine. This is the sleeve. It's the bore size on the original bore size is 5.5, and this is a little less than 5.5 inside diameter, and it's 1/8 inch thick. So we got plenty of material to work with here. This is pretty much up to the end of the size ranges in the Melling catalog. It was available from Melling as a regular automotive supplier. And I've got the ruler through here, and it's 20 inches from one end to the other. There's a 3-inch deep relief cut in the top end of the cylinder, which is up here toward the boring bar. It's probably 3/8 of an inch bigger bore, and then it's got a 45-degree angle chamfer that comes down to the cylinder. So that 3 inches there from the 20 is 17, but I'm not going to bore it all the way through. I'm going to leave about a 1/2 inch step for it to rest against. This sleeve is 20.5, so I'm going to have to trim the sleeve and put a 45-degree angle inside chamfer on it before I press it in. Spent quite a lot of time getting it lined up on the machine, and I'm about to end up my first trial cut, which looks like it's right about down the middle. I was really amazed, because this whole job is like 98% feel. You can't see what it's doing. It's almost like boring a blind cylinder. So I'll show you how I set the tool each time. Stop the cut when it gets about a 1/2 inch from the end here. Not really critical, just kind of eyeball it. And then I'll set up something so that I know where to stop on each additional cut. You might be able to see the relief here. This is 3 inches up here. Relief. measure this sleeve. There's a lot of ways to do this, and the way I'm going to show you is the way I do it. It's just worked for me. Lay out 2 lines 90 degrees apart, and I'm going to make 6 measurements here, 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 and over here, 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 and here, and average them out. We get a real good feel on this. $752.5. 5.752.5. Okay. There's the 6 numbers. You add them up, divide by 6. So when you do the math, the average OD is 5" 755 2/10. Gonna bore the cylinder for about 1.5 interference. So you can't go by what the book says, because the book says this is supposed to be 5.754. So that's 1/1000 and 2/10 difference from what I actually found here, which is probably within their tolerance, but when you're trying to fit it that close, you got to measure them every time. Well, as it works out, this counter bore is almost exactly 1/4 of an inch bigger than the bore, and I had to bore the bore out 1/4 of an inch to get the 1/8 inch wall sleeve in there. So what I'm going to do is, and this has to have a really good 45 degree bevel on it so that you can get the rings down through there. So I'm going to press the sleeve in, cut off straight, and I'm going to go back in there with a 45 degree cutter and cut that chamfer on there later. This hole over here is for the igniter. This is how the ignition worked on these old engines before they had spark plugs. It's got 2 electrodes that stick out here, and at the time the magneto breaks the spark, they come apart, and it causes an arc between the 2 of them. And believe it or not, it worked pretty good. With the sleeve cut off, I made a pusher or a puller plate. It just drops down in there, and this is made out of an old airplane propeller spacer. It's very, very good aluminum. I put a 45 on this side because I thought I would cut the 45 on here and then push it that way against the 45, but then I thought better of it because it puts a lot of outside stress on that sleeve, and I think it just would be better to cut the chamfer on it later. So that fits in there, and then I made this bushing here to go in here, and a 1" 18 threaded rod will go through there, and I have a hydraulic pump that I rigged up to pull this in, so I won't have to disturb the setup on the boring mill. That's the important thing. And then I can bore the inside diameter back out to piston size. It's got about maybe 60 thousandths I got to take out for this. Customer's going out of town this weekend and needs to take this thing with him, so I am forced to use a modern setup on this because of time restraints, and my arm gets tired turning that crank, so I decided to use my Porta Power. the sleeve's installed. What remains is to bore it to fit the piston and put a 45-degree chamfer on this edge right here. Last step is to hone the cylinder, get the proper surface finish, take out the last couple thousandths. Not very high tech. Customer wanted 5 thousandths piston clearance on this job. Personally, I think that's a little tight, but I doubt it'll get run very hard. There you can see the crosshatch on the cylinder. And this is the step that didn't get bored. There is a little bit of a ridge there that tells you that the piston doesn't run up here. So this is quite a bit undersized. Oh, like maybe 8 or 10 thousandths from the original bore. Of course, the piston is worn a little bit, but this will be a tighter setup than it was originally.